Alright, let's start with the very foundation of any software project, something called the Software Development Life Cycle, or SDLC for short. Think of SDLC as the roadmap or blueprint that software teams follow to build a product. It's a structured process that guides the work from start to finish, from understanding what's needed, to designing, building, testing, delivering, and maintaining the software. The main goal of SDLC is simple: to deliver high-quality software that meets customer needs, on time and within budget. Let's go through the main phases of SDLC so you can understand the bigger picture. 1. Requirement analysis. This is the starting point. In this phase, the team works closely with stakeholders, customers, users, and business people to gather and understand requirements. The aim here is to clearly define what the software should do, what features it should have, how it should perform, and what quality expectations it needs to meet. If requirements aren't clear, it's like building a house without a proper blueprint. You'll end up with mistakes and rework later. So this phase is very important. 2. System design. Once the requirements are clear, the design phase begins. This is where architects and developers create the blueprint for the software, defining its structure, technical specifications, data models, workflows, and how different parts will work together. Think of this as turning ideas into a detailed plan before actually building anything. 3. Development coding. This is the phase where the software actually gets built. Developers write code based on the designs created earlier. It's usually the longest phase of SDLC and involves constant collaboration. Developers work together to ensure the code meets requirements, follows standards, and maintains quality. This is where the vision starts to turn into a working product. 4. Testing. After development, the product moves into testing. The goal here is to check if everything works as planned. Testing looks for defects, checks functionality, ensures performance is good, verifies security, and confirms usability. This is an essential step. Without testing, you can't be sure the software will work reliably for users. 5. Deployment. Once testing is complete and the product is stable, it's deployed to the live environment where users can access it. Deployment can be done in different ways, sometimes in phases, sometimes in a pilot run, or sometimes as a full release, depending on the project requirements. 6. Maintenance. After deployment, work isn't over. Software needs ongoing support, fixing bugs, adding new features, and adapting to changes in business needs or technology. Maintenance is what keeps the software useful and valuable over time. Traditional approach to SDLC. Traditionally, SDLC followed a sequential approach, which means each phase was completed fully before moving to the next. This is often called the waterfall model. For example, first, all requirements are gathered, then all design is completed, then development starts, then testing, and so on. While this approach is easy to understand and structured, it has some limitations. If requirements change after a phase is finished, it creates delays and rework. Feedback from users only comes late in the process, usually after the product is delivered. It's slow to adapt to changes, which makes it less flexible. Why Agile came into the picture? Because of these limitations, Agile was developed as a new way of working. Agile focuses on iterative development, breaking work into smaller chunks, getting feedback early and often, and being able to adapt quickly to change. In Agile, instead of waiting months for a final product, teams deliver small, usable pieces regularly, getting feedback and improving continuously. Understanding SDLC and its limitations helps us see why Agile became so popular, especially in today's fast-changing world where speed, adaptability, and collaboration matter more than ever. So this foundation is important because it explains where Agile comes from and why it has become a preferred approach for modern software and project work.